Now let's look at logarithms. Now let's say we have numbers in the form b base to the power p equals a, right? If we have some number base whose power p and this is equivalent to another number a, then we can define a logarithmic function such that log base b of a is equivalent to p, right? So essentially you notice what has happened is that this number b, right, has gone to the base of the logarithm, right? The number a, which is the result of this computation, is the number whose log I am taking, right? And the power p goes here, right? So in other words, the log is actually the power of base b right, and this power is equal to a, right? So this is what this means. Now whenever there is typically logarithmic functions are a little bit confusing in the beginning, but if you remember this relationship, right, you will be able to find your way out of most problems pertaining to logs. Okay, so try and memorize this relationship, and this relationship will help you. In fact, going forward we are going to use these relationships only to prove all the properties, right? So let's keep this relationship in mind, and let's look at some of the basic examples. So let's say we have a number 10, right, whose power 4 gives me 10,000. Then log base 10 of 10,000 is equal to 4, right? So 4 is the power, 10,000 is the result of this computation, and 10 is the base. Another example, if I am given log base 2 of 8 equals 3, then this is actually another way of writing 2 to the power 3 equals 8, right? So this is how you can transform between, you can shift between one form and the other, right? Now anything to the base 10, right, anything in this form is called common logarithms, common logs, right? And anything to the base e, right, is called the natural log, right? So in case you notice that a question gives you a question is contains something in this form, log of 5, right? So you can simply assume, if there is nothing given in the base, you can assume that this is log base 10 of 5, right? If however somebody has to express log to the base e, the natural log, they can also write this in the form of ln, right? So let's say ln 5 actually means log base e of 5, right? But most of the time we are going to be using this log 5, right, which means log to the base 10 of 5. Now let's look at some of the basic results around logs. Let's see some of the results which are going to be used. Now if I have a number, let's say 5 to the power 0 equals 1, right? In fact, anything to the power 0 gives me 1, so I can write that log base 5 of 1 is 0, right? Now instead of 5 I could have had 6, 10, 15, anything. It means the generally the statement will be log any base b of 1 will be 0, right? So no matter what the base is, if you take the log of 1 you will end up with 0, right? So this is an important result that we must memorize. The other important result is 5 to the power 1 is 5 is the number itself, right? Which means that if I take the log, if I take this base 5 here, and if I take the log of 5 and I get 1, right, the result that I get from here is that log base b of the base itself will always be 1, right? So simply put, you take any base, the log of 1 will be 0. You take any base, the log of the base itself will be 1, right? This means that log of base a, right,